Hello, my Gen Chem students. Welcome to the last practice problem that I had in my notes for basic equilibrium. Head over to the notes. All right. A 1 liter flask is filled with 1 mole of H2, 2 moles of I2 at 448 degrees C. And then we found earlier that the Kc, and I gave myself some more sig figs, 50.5. What are the concentrations of all of these gases at equilibrium? Okay. First thing, do I have a balanced chemical equation? Yes, I do. Can I write out an equilibrium expression? Yes, I can. And this could be in pressure or in molarity. And it looks like I've given moles per liter, so it's in molarity. So HI squared over H2, I2. And then I asked myself, do I have the K value? And in this case, it was given. In the future, you'll have to look it up. So it's 50.5. All right, I have my balanced equation. I have an equilibrium expression. Let's fill out the ice table. What am I starting with? All right, a 1 liter flask with 1 mole. And remember, what goes into ice tables? Concentrations or pressures. So 1 divided by 1. So 1.123 moles divided by, oh, look how nice I was, a liter. And 2.123 moles divided by 1 liter. And did I start with any of the HI? And the answer is no. So this question did not put any in the original mixture. All right, this is going to change by negative x, gain 2x. And so at equilibrium, I'm going to have 1.00 molar minus x, 2.00 molar minus x, and 2x. Now, those aren't numbers, but I can still plug them in. So 50.5 is equal to 2x squared all over 1.00 minus x times 2.00 minus x. Oh, that's looking like some crazy math. The reason for this problem is to show you the crazy math so that when I do some assumptions later on, you'll go, yes, thank you, thank you, thank you. All right, I'm going to go over to the whiteboard and let me see if I can remember those numbers. I should be able to. Should and will being two very different things. All right, so here was my math problem. 50.5 is equal to 2x squared all over 1 molar minus x and 2 molar minus x. Okay, so the first thing I'm going to do is I'm going to multiply the 1 and the 1 minus x and the 2 minus x together. I'm probably going to do this differently than you guys were taught. It does not matter, but an x times a negative x times a negative x is an x squared, and negative x times 1 is a negative 1x, and then 2 times a negative x is a negative 2x, and then 1 times 2 is the big old number. I ran myself out of room. Surprise, surprise, is 2. So this answer right here is x squared, and I'm just flopping the order, minus 3x plus 2. All right, so that is that piece. All right, I now have to multiply that by 50.5. So 50.5 times x squared equals 50.5x squared minus, where's my calculator? You guys are probably going to zoom right to the end, and it'll seem like this calculation was so easy. All right, 50.5 times 3 is a negative 151.5x, and then 50.5 times 2 is 101. Whew, I still don't have it in a form where I can use the quadratic equation. So now I'm going to combine like terms, and get one side to be 0. So I'm going to subtract 4x squared from both sides. And I'm going to end up with 46.5x squared minus 151.5x plus 101 is equal to 0. I am now in a form that I can use the quadratic equation. So minus b plus or minus the square root of b squared minus 4ac all over 2a. And that is on your reference sheet for you. But in the future, I'm going to give you some shortcuts anyway. Okay, let's plug it in. This piece is a, this piece is b, and this piece is c. So I have a minus b plus or minus the square root of a negative 151.5 squared minus 4 times 46.5 times 101 all over 2 times 46.5. All right, in the end, I'm going to come up with 151.5 plus or minus the square root of, so 151.5 squared, that one is 22,952, and then 46.5 times 4 times 101, and that is subtracted. So underneath, I'm coming up with 4166.25, and I'm going to do it again just to confirm. 151.2 and 4 times 46.5 times 101. And I'm going to subtract that, and I came up with a different answer, so I'm going to try it one more time. 151.5, 46.5. All right, so 4166.25. Now, that is not correct sig figs, but 66.25. I'm going to take the square root of that, and that roughly is 64.5. All over 46.5 times 2. All right, is 93. Okay, now I'm going to do the plus variation and the minus variation. So for the plus, it is going to be 151.5 plus 64.5, all divided by 93. And that is going to be 151.5, 64.5, 93. That is going to leave me 2.3, and let's just keep 3 sig figs, 2.32. The minus variation is 151.5 minus 64.5 divided by 93. Just making sure. All right. 151.5, 64.5, 93 is 0.939. And remember, I just solved for x. So I have two values of x. So let's go back to our ICE table. Which one makes sense? So I have an x of 2.32 molar, or I have an x of 0.938. This one doesn't even make any sense. You can't have more molarity than you started with. And so one of the answers should always be nonsense for you. So I just found x to be 0.938 molar, and then I'm going to plug that in. Multiplied by 2 is 1.88. I'll change colors. All right, so this is 1.88 molar. 2 minus 0.938 should be 1.062, and I only get 2 after, so 1.06. And 1 minus 0.938, and I only get 2 after, so it should be 0.06. Woohoo! Okay, that was a long way to actually solve the problem. So that wasn't the chemistry, that was the math that was associated with it. Wow. Do I have to do that? And the answer is technically yes. Okay. We can get our problem into some kind of math form, and then we're just going to use our math skills to solve it. This one happened to go into the quadratic, but in the future, I will show you a way to kind of tweak and get around that. So usually I give you a way from the ice table to find x, or in the future, I'll give you a way to kind of, fudge and get out of that. All right. Make sure I don't have any more problems hidden here for you. All right, so that was question, let me see, 4, 1D, or it was the fourth practice problem. All right, till next time, jolly out.